Well, good afternoon to all of you. I will now talk about a research project we are carrying out at the University of Liechtenstein. This is more or less, I'd say, well, the application of the certain principles that Peter Dröge has this afternoon mentioned in his more conceptual presentation. So I will talk about essentially about the background of our project. I will introduce you to the region, and I will just give you a broad overview of what we are doing at the moment. This is really work in progress, so I have some preliminary results I can present to you, but this is not a project which has been completely finished. So what is and where is actually what we call the Alpine Lake Constance Alpine Rhine Energy region? This is actually the border region between Austria, Switzerland, Germany, and also including Liechtenstein, which is as a whole, of course, part of the region. It has around 11,000 square kilometers and comprises almost 4 million inhabitants. This region is quite famous for cross-border cooperation. Cross-border cooperation started there in the early 1970s because the Lake Constance, which is a major sweetwater body in the close to the Alps, was in the threat of being completely polluted by the surrounding villages and the surrounding industries. Thus, the bordering countries agreed on certain measures first in order to improve the water quality, and later on, this cross-border cooperation was also extended to other fields within the context of in the environmental context, but also onto the fields of promoting business and cultural exchange and other things. Energy is becoming more and more an issue in this region. I think one could say that all countries that are involved have there's a high degree of awareness of the importance of energy issues. Vorarlberg in Western Austria is famous for that. Also, Switzerland does a lot of energy research, and Germany is famous for its Energiewende, which is on the way. And Liechtenstein can benefit from all these experiences all around, let's say. So what we are working within a larger framework, which is defined by the so-called Internationale Bodenseehochschule, International Lake Constance University, which is actually a cooperation of different universities and universities of applied science, which gather around this lake. And why do we talk about energy and climate change and renewable energies in this area? Well, as you can see it behind me, it's a very nice place actually. This is the northern part of Liechtenstein at the border to Austria. But of course it shares the same problem as any other region in this world. This region is also highly dependent on fossil fuels in the industry, in the transport sector, in the housing sector, and of course it is also contributing to climate change, and it will also suffer from the severe consequences that may be the result of global warming. So this is the background of our project. We are working together with 4 other partners from the framework of the Internationale Bodenseehochschule. One is from Germany, the University of Applied Science in Constance, and 3 are from Switzerland, from St. Gallen, from Winterthur, and from Rapperswil. Unfortunately, there was no possibility to involve an Austrian university because there is, no university. There's just a University of Applied Science, which at this time did not carry out energy research. This has changed in the meantime, but still we are, of course, also looking at the Austrian part of the region. The goals of this project are, to boost research and to contribute to, let's say, the growth of knowledge on energy matters in this area, in the region. And of course, we are not just interested in scientific outcomes, but of course also in communication and in bringing together people that are interested in these subjects all across the region. This is, I think I've already mentioned. We have at least two focus groups, two target groups. One is the scientific community, and the others are the local decision makers and stakeholders. These are the partners that are involved. We have different fields we are working in. The leaders with the University of Liechtenstein. As Peter Dröger has already mentioned, our background is urban planning and urban design. Also transport research. This is something I'm working at in Liechtenstein. But we have an interdisciplinary team also with economists and with technicians, electric technicians from Winterthur. A couple of people are working within this team in Liechtenstein and elsewhere. And the good thing about this region is, as I've already mentioned, that there's quite a lot of good examples, best practices one could learn from. There's, for example, the state of Vorarlberg in Western Austria, which has committed itself to the goal of energy autonomy until the year of 2050, which is more a long-term goal, but still, I mean, it's very progressive to commit oneself as such a big region to such a goal. And there's also, something like a model town in Wildpolsried in the northeast of the region, which belongs to Germany, which is something like a suburb of the city of Kempten, which already covers, I think, around 400% of its own energy demand by renewable means. And there's also a bioenergy region close by. So this is the context we are working in. What do we actually do, or how do we cooperate within this framework? I mean, the universities are not close to each other. There's a distance of maybe 100 kilometers or 80 kilometers between the different universities. Of course, we share a motivation. We all know, and this has been broadly discussed here at this conference, that of course the consumption of fossil fuels and leads to global warming, and of course that the dependence on fossil fuels puts the whole region at a big risk, and that of course such a development is not resilient in a way. So we suggest that the whole region should commit itself to the goal of energy autonomy, as many regions have already done on a smaller scale. And this will, as we think, or we are quite sure, we are sure about this, this will not just lead to a reduction in greenhouse gas emissions, but this will essentially lead to a very far outreaching change of the energy supply system and also of the, let's say, the urban system. Because, nowadays we have a very centralized energy system that relies on imported energy, and the future energy system based on local and regional renewables will be, of course, much more centralized. This will have quite far outreaching consequences for the villages, for the cities in the region. We know that one could even construct houses that generate more energy than they consume. And if you consequently apply the principle of production of renewable energy to at a small scale, this will lead to new forms of settlement, new forms of architecture that we can hardly imagine today. Of course, this will also have consequences for the planning system. There has been quite an effort has been carried out in the last years in order to develop new models which can be used in order to estimate the potentials for renewable energy generation at a decentralized and at a small scale level, measuring and assessing the potential of different buildings types and settlement types. And this is something we also use as a background for our research project. Professor Dröger has already mentioned this afternoon, that we work with a bottom-up energy model. This is something you can see behind me now, which works differently than the, let's say, conventional energy models that have been used for decades, that were usually based on macro data, derived from the national level, somehow applied to certain, well, regions and sub-regions. This is a bottom-up model that actually, let's say, calculates the energy consumption, also the potential for the generation of renewables based on, well, units of a very, very small scale, actually on something we call space types. And there's something like an underlying, I can show you this on this slide exactly, an underlying building topology. If I go back once again, there you can see this, what we call space types. These are areas which have more or less a homogeneous, well, building typology. And thus we assume, or thus we know that they also have a similar, well, energy consumption and also the decentralized potential for the generation of renewable energy by solar panels on the roofs or on the facades or by heat pumps is also homogeneous within these small space types. And we use this model, we share this model with our partners in order to estimate the energy, well, consumption of today, the potential for the generation of renewable energies, and also in order to carry out or to develop scenarios for the future development of the region. While we are at the moment doing that for the whole region, we have already finished a pilot study, like, let's say 1.5 or 2 years ago, for Liechtenstein. This was really a pilot. We just, tested the model for the very first time in our context. This is something you can see behind me. Here you see the space types on the map, and these are actually the outcomes. You see the line with the circles. That is actually the consumption, and you see the columns. That is the potential for the generation of renewable energy. And we developed 2 scenarios. This is actually the trend scenario, and this is something like the efficiency scenario. And the result was actually that it could be possible to, well, let's say quite easily, or at least if you apply, well, cutting edge, let's say, or far-reaching new technology to generate as much electricity which will be needed in Liechtenstein. It will be more complicated actually with caloric energy. This has to do with it's more difficult to increase the efficiency apparently, and also there seems to be something like the threshold which is difficult to be crossed for the introduction of heat pumps. So, well, this is actually something like a snapshot of the model for the whole region. We are working on this. At the moment we are carrying out quite a lot of detailed studies for for prototypical local communities. Of course, we cannot look at all the communities. There are 450, something like that, in the region in detail, but we have a certain sample and we are analyzing the sample. So this is something like the shared working platform. We also do, of course, some kind of teaching, and this is, let's say, the more visionary part of our work, that we just show or present our ideas of the future energy system and of the future settlement structures or the requirements for future developments in urban planning and urban design to our students, and ask them what they think about it and how they could imagine what these new settlement forms and architectural forms may look like. We are doing this in Liechtenstein. Also our partners in Constance do that, who are also architects. And well, this is just, this is one of the outcomes. This is actually, of course, there's some irony. It's within this collage. We also do, let's say, more serious urban designs. This is, of course, something like a caricature almost. But the good thing about these collages is, of course, that they're easy to understand, and you can discuss this with people who have a different background than architecture and urban design. And of course, most people find that quite interesting. So, of course, also we try to spread our results to the scientific community and to the regional stakeholders. We do that by organizing and by attending conferences like this one today. We have also published quite a lot so far, and there's also something like an atlas on the way. That's been, we are developing this. There's a web-based, Google-based map of the region where one can, register and upload projects dealing with renewable energies that he or she is carrying out at the moment. So we are trying to communicate with all the people who are involved in this business in the area. Well, this is just too early. Now the project will be done more or less at the end of this year. We have now started something like an implementation phase. We are going to organize workshops with regional stakeholders. There will be one at the end of June in Liechtenstein, and we will also try to organize these workshops together with the Internationale Bodensee-Konferenz, which is the transnational platform of cooperation. And of course, we are eager to start new projects on this matter. I mean, we're interested in this we've been interested in this for a couple of years, and of course, we want to continue with this. And hopefully there'll be a BAER 2 and a BAER 3 and a BAER 4 afterwards. So I think that's all for now, for today. Thank you for your attention, and I'm eager to answer your questions.
Thank you. Thanks to all the speakers for their time discipline. I want to take one or two quick questions before we have a short panel reflection here. Are there any questions on that very project? Yes, there's one over there.
Just a question of clarification, Gerd Stimmeder from the Austrian Ministry. What exactly, if you understand energy autonomy, so to say, how do you include mobility? Do you include all buildings? Do you include further business activities and so on? Or do you take it rather from a static view?
Well, we take essentially we take into account all energy parties, also mobility and also industry. But I have to admit that we are looking more closely at the building stock, which has something to do with the model, of course. I'm trying to develop something like an extension of the model for the mobility sector, which is based on survey data from the state of Vorarlberg and also from Switzerland. But there's, of course, let's say the grain or it has a different scale than the building model.
Okay.
The industry sector, the industry part is based on macro data, actually.
Sorry, is it a dynamic view? What will happen in the larger region?
Sorry?
Does it include a dynamic view? So to say, I mean, the southern Germany, for instance, is quite active.
Yeah. Yes, it does. Mm. Yes, it does. Mm.
Okay, I don't see any further questions right now. So, yes. Yeah. Wait for the microphone, please.
That software you were talking about, is that a software design tool or is that an analysis tool? Because we always have these problems in which parameters we are putting in order to getting out the right information at one side, and at the other side, what are we doing with it? So the meaning is it an analysis tool or is it a software design tool? It was just one slide.
I think it's not a software design tool. I wouldn't call it a software design tool. It's, I think, an analytical tool. But it can be used also for the development of scenarios. And while we use the outcomes of these scenarios as for the discussion with regional stakeholders, and also as a starting point for the analysis of institutional changes that would be needed in order to achieve the goal, let's say, of energy autonomy.
But basically, it's going about exposure and potential of energy production with solar panels and so on and so forth.
Yeah, exactly. This is the first step, and the second is the institutional analysis, actually.
Okay, thank you.
Thank you.